Hi, everyone. On behalf of the Russell Sage Foundation, the Alfred P. Sloan Foundation, and Duke University, it's my pleasure to welcome you back to the Summer Institute in Computational Social Science. Today, we are going to be talking about surveys in the digital age. So to place what we're talking about a little bit in perspective, I want to go back to some images we talked about on the first day, particularly the contrast between Fountain and David. And so during the last 2 days, you learned a lot about text data and screen scraping and so on. And that kind of data is generally ready-made data. Not exclusively, but generally. And so you learn some about the problems and issues that arise in working with ready-made data and also to some extent collecting ready-made data or getting ready-made data. So today and for the rest of the days, we're going to pivot into more areas that are custom-made, where researchers play a much larger role in the creation of the data itself. So this brings with it opportunities, and it brings with it problems. And we'll increasingly see ways that these two approaches can be combined fruitfully. But so the big difference now is we're going to play a much bigger role in what's happening in terms of the way the data comes into being. OK, so the schedule for today is I'll give a brief introduction, and then I'll talk. The main part of my talk will be split into 3 areas. One is related to sampling, one is related to interviewing, and one is related to combining surveys and big data sources. Then we're going to have a pretty long introduction to the group exercise, because there's a lot of stuff that you need to learn to do it. Basically, what you're going to do is you're going to create a survey, deploy it on Mechanical Turk, and analyze the results, trying to adjust for the fact that the people on Mechanical Turk are not like everyone else in the world. Everyone else in the US is particularly what you're going to deal with. And so we're going to leave as much time as we can for this exercise. So we'll continue with the exercise into the afternoon. Then we'll come back together. This time, we're going to have a little bit more time to come back together and talk about what you did. And then we'll also talk about how you can open source your data. So what we're going to do is the data that you create, you will then make available to other researchers. In this case, it's a little bit unlikely that other researchers would want to use this data. But I think it's very good practice for you to think, at the beginning of data collection, I'm going to release this data. And this you can think of as a pilot test for your group projects, where if you're going to receive funding from us, you will be required to release your data and your code and make your manuscripts available open access, pending. So making your data available, obviously, there are potentially issues related to privacy. We will talk about those as well. OK? This afternoon discussion will not be live streamed, but for people at the partner locations, all the slides that I'm going to use are already on the schedule. Then we'll have a little break, and then we're very excited to have a guest speaker, David Lazar. OK. So let me just talk a little bit more about my style and how I'm going to do my teaching today. So first is I'm going to have an anti-status quo bias. So that means some of what I say will probably be wrong. But let me explain why I'm going to do this. So you don't need to come here and have me tell you stuff that you hear a bunch of other places anyway. And so I'm going to try to tell you stuff that you might not be hearing other places. And the hope is that this will be helpful in terms of getting excited about thinking about surveys in new ways. I also, in this teaching, I'm going to have an anti-formality bias. So I'm going to say certain things. I'm not going to formally specify the conditions under which these things are true. I will try to give insight about those conditions. There is a place for formality, absolutely. If you look at my papers, they have that kind of structure. But I don't think that's the most important thing right now. Some of you have never worked with survey data at all before. And so this is not the best setting to have a very formal lecture about surveys. And I'm also going to be relatively brief because I want to leave as much time as possible for the activity. So if you would like to know more, a lot of this is covered already in Bit by Bit Chapter 3. OK, So one of the questions I get most often about surveys is, why should I care about surveys? So there is this idea among, I would say, many data scientists and some social scientists that surveys are old-fashioned, surveys are broken, surveys are expensive. We don't need surveys when we have digital trace data, because digital trace data gives us a direct window into the truth. And surveys are an incredibly broken instrument that doesn't reveal what people think they reveal. So obviously, as we've learned for the last 2 days, digital trace data does not give you a direct window into the truth. And there are certain things that you can do with surveys that you can't do with digital trace data. So surveys have proven to be a very important measurement device in the social sciences for the last 50 years. Most of what we know about the social world that comes quantitatively comes through surveys. And so I think it would be unwise to completely discard this measurement device that has worked so well for so long. But I do think we do need to think about how we can use this device in new ways. How can we modernize the way that we approach surveys? Because there's a lot of stuff that we could do now that the pioneers of survey research could not do at all. So why should I care about surveys in the age of big data? Again, I think that the reason is that big data has a bunch of problems. I'd like to illustrate why I think surveys are not going to go away. And the first is the limitations of big data, and particularly there's this FUBU versus new FUBU. So FUBU, so if anyone here is my age, they will remember this company called FUBU that was very popular when I was in middle school. They made clothes, and it stood for us, by us. And I think most big data sources are NuFu, NuBu. They are not for us, and they are not by us. So I think a lot of the problems that Chris talked about over the last 2 days come from the fact that a lot of these digital trace data, they're not collected by people who are interested in doing social research in the kinds of questions we're interested in, and they're not intended for that purpose. So there are a lot of things, for example, that companies actively don't want to collect that researchers might. So for example, many companies might not want to know things about the race and ethnicity or the religion of the people who are using their platform. Many researchers actively want to know that stuff. Many companies may want to know the credit card numbers of the people using their platform. Many researchers probably don't care about the credit card numbers. And so you see there is this kind of fundamental differences in the kinds of things people care about. And then there's also a difference in the way the data is created and stored. So for example, social researchers might be interested in knowing about the complete sort of evolution of the Twitter graph, let's say. And so if you were interested in that, you would need to store the data in a way that enables that calculation to be made. But if you're Twitter and you're interested in running a service, all of that information is not necessarily important. You mainly, potentially, you only need to know what's the state of the graph right now. And I want to store the data in such a way that I can do things with it as quickly as possible. And so even in the way that data is stored and archived, often social scientists get frustrated when they see how these things are done. And again, that's because of a difference in goals. So I think that is a major fundamental limitation, and that is not going away. So like, I like to think about what are the things that are going to stay the same, and what are the problems that are going to go away as technology improves, and what are the problems that aren't going to go away. So if you said, oh, a big problem we have is that we don't have enough hard drive space, I would say, well, okay, I'm pretty sure that's going to get easier and easier over time. Or we don't have enough computing power. That's going to get easier and easier. The difference in alignment between people working at companies and between people working in universities in terms of the kinds of data they're interested in collecting and the way they store it, I think that is not going to change. Second is there's an important difference between internal states and external states. So sociologists in particular are often interested in things like attitudes, expectations for the future, emotions, things like this. And these are internal states. They're very different from behavior. So you can say, I can measure people's behavior. I can measure how often you buy something, or I can measure how often you read certain things in the newspaper. And sometimes we may actually care about your behavior, but sometimes we may care about your internal states. And it can be very tricky to infer internal states from external behavior. And so if the thing that you care about is internal states, like emotions, like attitudes, then often the best way to learn about them is to ask. So let's say I want to know your attitude about the war in Syria now. So that is something that researchers may be interested in, that either as an outcome, they want to understand why you have the opinions you do, or they may want to understand how that opinion shapes some other thing. And so even if I had all of the data about everything you do, all of your behavior, it's potentially very tricky to infer that internal state. And so that's why often when we want to know about internal states, like how you feel about the war in Syria, we ask you. So the third reason why I think we will always need to ask is the inaccessibility of big data. So as we've talked about before, it's basically most of the data that we would like to have access to, we don't have access to. And that is also something that I think is not going away. So I had, a few years ago, I used to think, oh, these companies, what are they doing? They should just give us access to this data. Why are they being so greedy? And don't they realize how we're going to help save the world? And then I spent a year at Microsoft Research, and I saw that the people inside of these companies also wanted to do nice things, and they're just fundamental legal barriers, they're fundamental privacy barriers. As a customer of some of these companies, I'm actually happy they are not giving out this data. Like my cell phone provider, I am really happy that they are not sharing data with researchers, as far as I know. There may be certain ways that it could be done responsibly, but that is a very, very hard problem, and I think that problem will not go away as technology improves. And so all of these things, I think, are really fundamental barriers that will not go away. And so I think we're going to continue to see surveys as a big part of the research endeavor for the foreseeable future, even as technology continues to improve. But that doesn't mean we should do surveys the way that they were done in 1950. So just stepping back briefly for those of you, I want to give a tiny, tiny history of survey research, because I think it helps inform where we are today and where we're going in the future. So the first era of survey research, which you could say started around 1940, let's say, the sampling, there are two main parts to a survey, is finding the people to talk to and then talking to them. So those are two really very separate things that we shouldn't blur together. And so in the first era of survey research, there was area probability sampling. And so in this, they would generally pick certain areas randomly and then send interviewers to go to those areas and knock on people's doors and ask them questions. So these interviews were all done face-to-face. And so this went on for a while. And then in the 60s and 70s, in wealthier countries, there was a technological change. So there was widespread diffusion of landline telephones. And some people said, hey, there's this big change in technology. We could use this to do surveys in a different way. And so they started doing random digit dial probability sampling, where they randomly pick phone numbers. And then the interviews would take place over the telephone. This is kind of the framework that many of us social scientists have learned about. The transition, however, was incredibly contested. So when people said, let's do these random digit dial things and talk to people over the telephone, people said, you can't do that. Not everyone has a telephone. And that was true. And people may answer differently over the telephone than they would face-to-face. And that was also true. But eventually, researchers worked on these problems and solved them, because the advantages of doing telephone surveys were substantial in terms of decreasing cost and increasing speed. And so basically, now we're moving into this third era. Different parts of the field are sort of further or less further along into this third era, where we're going to, I think, increasingly see non-probability sampling and computer-administered interviews. And again, we're hearing some of the same concerns. How can you do this? The people who have access to these online platforms are different than the people who don't, and that is right. And the way people respond to computer-administered interviews may be different than telephone interviews. That is right, too. But the benefits from being able to do these third-era techniques are so great that we are going to have to eventually solve these problems. And so when you hear about the problems with these third-era techniques, I think you should think about them as not a reason to avoid them, but a reason to start doing them, right? This is something we need to solve, and if we can solve these problems, we can make a lot of progress. Now, there's one other thing about this third era of survey research that I think will become very common, is that increasingly we'll see surveys linked to other forms of data. And so as the amount of ready-made data in the world grows and grows and grows, it becomes increasingly difficult to just run a survey by itself and think that's going to be all the data that you're going to need, right? Like the pure custom-made strategy becomes harder and harder when there's all this other stuff. And so increasingly we'll see many more surveys that are linked to administrative records or big data sources, or vice versa. You can think of them as big data sources that get linked to surveys. So there's sort of different ways in how you think about this relationship, but increasingly we'll see these two things working together. And so the structure of the lectures today will be one on this piece, one on this piece, and one on this piece. Now, before going into each of those pieces individually, I want to talk a little bit about the total survey error framework. And so what this is, there's all kinds of problems with surveys. And everyone who's done surveys knows about these problems. To me, so over many, many, many years, many people have tried to create a framework that sort of includes all of these different errors as special cases. So like, how can we have a framework that helps us think about everything that can go wrong in surveys? And if we have that framework, then we can quantify those errors and also, ideally, design surveys to help minimize those errors. And that's what the total survey error framework is. And so that is something that is sort of technology independent. So I think that the total survey error framework, it made sense 50 years ago. It makes sense today. I think it will make sense 50 years from now. I think it will make sense 100 years from now. The actual components will be different, but the framework will be the same. So let me talk a little bit about this framework. So there's two main components. There's errors that come from who we ask. This is sometimes called representation. And then there are errors that come from how we ask. So even if we do a census, for example, let's imagine we talk to every single person and we ask them, let's say, how many times did you go to the doctor 10 years ago? Like, you have no sampling error, but you potentially have a lot of measurement error. And so we should also think about what are the kinds of errors that go away as we get more data, and what are the kind of errors that don't go away as we get more data. And I think particularly a lot of these measurement errors do not necessarily go away as we get more data, and so they're going to become increasingly important. Okay, so just to put these total survey error into the context of a modern example, so this is the inauguration of President Trump. This was a surprising event to many people, given that polls had predicted that he wasn't necessarily going to win. And so after this, APOR, which is the major survey research organization in the US, had a blue ribbon panel to try to figure out what went wrong in the 2016 polls. Why is it that they made this incorrect prediction? And so basically, what you can do is you can think that a lot of their answers are going to come down to either one of these two buckets. There are going to be problems with who we asked, or there are going to be problems with how we asked, what we were able to learn from the people we talked to. So let me now walk you through a little bit about who we ask and the different ways people like to think about the errors that arise. So survey researchers like to think about a target population. So this is the group of people that you want to learn about. So this could be registered voters in the US, or it could be adults in the US, or it could be researchers interested in computational social science. Whatever population you're interested in making an inference about. If you hear someone make an inference about some population, it's often a good thing to say, what is the population you are trying to describe? And if they can't answer that question, that is potentially a yellow flag. So once you have this target population, then you often are not able to fully access that population. So you have to have a frame population. This is the population from which you're going to take a sample. So let's say we're interested in registered voters in the US. Your frame population might be people who have telephones. So now, not everyone who has a telephone is a registered voter, and not all registered voters have telephones. So any difference between the target population and the frame population is called coverage error. And so coverage error is a problem, particularly for certain kinds of populations, like people interested in computational social science. So if I was going to try to do a survey on that group, I would think right away, all right, I'm going to have a really hard time finding a good sampling frame. And so even if your sample gets really big, that's not going to solve this problem with coverage error, because you will never learn about the people who are not on the frame population. Okay? So then once you have the frame population, then you take a sample. So let's say with the telephone surveys, you would sample 1,000 people. You would call them. And then what happens is most of those people don't talk to you. They don't answer their phones. Or if they do answer their phones, they don't want to talk to you. So often if you want, let's say, so then this next step comes in, which is non-response. And so then after this non-response step, we get the respondents that we actually talk to. And so the goal is to use these respondents to then learn about the frame population and then potentially the target population. So this last step is also very important, increasingly, because response rates are very low. So for sort of commercial telephone surveys, response rates are now around 10%. Another way of saying that is non-response rates are around 90%. Those are equivalent statements, and one sounds scarier than the other. So what is happening is it's getting harder to contact people, and people that you do contact are less likely to participate. And so what that means is you have to learn about this much larger group from this relatively self-selected group of people who agree to participate. So this is the sort of way to think about who we are asking. And I should also add that the confidence intervals that we normally see in surveys and estimates from samples generally only apply to this kind of error, the sampling error. And they don't apply to non-response error generally, and they don't apply to coverage error generally. So we're missing some of the most important parts of the error. And if we increase our sample size, the confidence intervals get smaller, but we're not capturing this kind and this kind of error. Okay? So that's what I just said. All right, so now to the second piece of who we talk to, or what we learn when we talk to them. And so here there are a number of, this representation framework, you can work this all out mathematically. We could write down some formulas, and it all has nice formalization. This measurement stuff is much harder to formalize. But people have worked for many years in surveys, and they found a bunch of ways that the ordering of the questions can make a difference, or the exact wording of the question, or the word choice. And there are many, many, many results like this. And I think we don't yet have a full, beautiful framework to understand all of these, with the exception maybe in certain parts of psychometrics, where the measurement models are pretty formalized and nice. But we know that these things absolutely affect the results of your survey. And when you are designing your survey in a few hours, you will have to think about these exact issues as well. So now that we've had this background about the total survey error, let's look at the results of this APOR report. And as we read these results, they're expressed in a sort of specific way about what happened in 2016. But we'll see that these are actually manifestations of these more general things. And I'm sure that everyone who worked on this report knew about these more general things. So the first thing that they concluded was that national polls were generally correct and accurate by historical standards. So that's like, we didn't do anything wrong. Which is not totally incorrect, but on the other hand, if you think about, often data is collected for a purpose, and like the purpose is to predict who would win, and so based on that, it didn't work that well. Even though on aggregate, it was actually pretty close to what happened. They say that state-level polls showed competitive and uncertain contests, but clearly underestimated Trump's support in the upper Midwest. So here's some quotes now from the report. There are a number of reasons why the polls underestimated support for Trump. The explanations for which we found the most evidence are: 1, real change in vote preference during the final week or so of the campaign. So this is, surveys weren't wrong. This is the number one part of their conclusion. But this, by the way, will also come up in your activity today about real attitude change as a potential source of error. Second, adjusting for overrepresentation of college graduates was critical, but many polls did not do it. So this is about who they talked to. So generally, they were more likely to talk to college graduates, and they didn't, in part because of the way that their sampling frames were, in part because of the non-response patterns, and they didn't appropriately adjust for this fact. So this is a representation issue. Some Trump voters who participated in pre-election polls did not reveal themselves as Trump voters until after the election, and they outnumbered late revealing Clinton voters. So this is a measurement issue. So some people might have chosen not to tell someone on the phone that they were going to vote for Trump. So you can see that and then it's very hard to disentangle which of these was the dominant factor, although they sort of think both were at play. So here we can see the total survey error framework helps us understand this particular thing that happened. And if you want to get the full report, there's the link. So wrapping up, the total survey error framework helps us organize all the things that can go wrong. It's very useful when you're designing a survey because you want to, as much as possible, minimize those problems. It's very useful when you're thinking about someone else's survey. So someone presents you some results that come from a survey. So right away, one of the first things I do is I think about the total survey error framework, and I think about the representation and how that was handled, and I think about the measurement and how that was handled. And it's very useful for yourself when you're analyzing your own data to try to be honest about the errors that you have in both of these kinds of errors and report them and be as clear as possible about how those could potentially affect your results. It also is going to help organize the way we think about survey research in the digital age, which is going to come next. And to learn more, I recommend this book by Bob Groves et al. It's a really good introduction to survey research. It includes issues related to representation and measurement. So now we have time for some questions. Any questions here? Questions from the live stream? Yeah, Natalie?
I know you wanted us to go and read the whole report, but can you briefly explain how they separated actual change from unwillingness to report?
I think it's very difficult to separate those things given the data that we had. Because again, those data weren't necessarily designed to answer that question. And so my guess would be that in the next elections, there will be studies that are going on that are specifically designed to address those questions. But I don't think we'll ever really know about this one definitively. OK, any more questions? Should we? OK, let's move to the next section.